So we're at supercomputing because it's kind of the place to be for HPC. It's where everybody gets together, and it gives us a great platform to reach out to industry leaders and to show them how our products and immersion cooling in general can really transform HPC. We're talking about things like increasing density, increasing efficiency, all while reducing our environmental impact. And it's just kind of nice to be around people who understand those challenges and see the potential. So we're trying to solve a pretty big problem, and that is, how do we deliver to data centers a cooling solution, a high performance cooling solution that's both sustainable and energy efficient? DLC, which is kind of all the rage right now, it does a really good job of cooling hot chips, but when it comes to sustainability and energy efficiency, it falls a little short. And that's because typical DLC setup is, it has two components. There's the pure DLC component and there's the air cooling component. And the PUE is essentially a weighted average of the PUEs of those two technologies. With immersion cooling, it's not that way. There is no air cooling component. It's just one loop, and the power required for cooling is just the power required to power on a couple of pumps and a couple of fans. That's how you get down to a PUE of down to 102. And so with immersion cooling, you kind of get the best of both worlds. You get high performance cooling, but you're saving a lot of money and energy in the process. About 3 years ago, CPU TDPs were under 300 watts. And at that point, it was really easy to, immersion cooling was really straightforward. You took your air-cooled server, you swapped out the TIMs, you put it in your immersion tank, and it was fine. But then when TDPs hit 350 watts, we started getting questions from everybody about how you're going to cool 500 watt CPUs in the future. And at that point, we decided to allocate a lot of resources to improve our chip level cooling. And last year, we were the first to show at supercomputing, well, at OCP and supercomputing, we were the first to show an overclocked Xeon in immersion. We did that with our forced convection heatsink system. We call it the FCHS. And with that setup, we were able to overclock a Xeon to 820 watts, which was, it was a lot of fun, really cool. But this year, we also have some cool demos. We've got 2 of them this year. The first demo features targeted flow on an NVIDIA GH200 system. And to our knowledge, it's the first instance of a GH200 being immersed. So that's pretty neat. And the second demo is targeted flow on an Intel Granite Rapids system. The neat thing about that demo is the inlet fluid temperature is actually 70 C or greater, so it's quite literally hot. And like the other demo, it's the first of its kind. SmartPod XO is our brand new flagship product. Production on it starts next year in the United States. We designed it with high performance in mind, so we're talking about industry-leading performance, 360 kilowatts using chilled water, 5 nines availability, so that's with the twin tank configuration, which what's shown over there is the unit tank configuration. That's essentially one tank, one CDU. The twin tank configuration is 2 CDUs, 2 tanks. The idea there is that should one of those CDUs go down, the healthy one basically takes over for both tanks. And in that situation, your thermal capacity gets reduced to about 250 kilowatts, but that's still really, really good, industry leading still. And then finally, the flexibility, I think, is what really sets it apart. So you're going to notice a manifold. With that, you can use new technologies such as targeted flow, and there is what we call dry zones in the front and the back. You can put PDUs there, you can put switches there, basically anything you want. And then finally, the interior of the tank. It's 50 rack units, and that can be adjusted to accept basically any form factor. So it's 19 inches there now, but you just add different brackets and you can use OCP compliant servers. Targeted flow technology works. It's similar to DLC. You have a cold plate like heatsink on the CPU or the GPU. The main difference is that with DLC, the cold plate has an inlet and an outlet so that the water can come from and to the manifolds. With targeted flow, there's only an inlet. And so the fluid gets pumped from the manifold to the inlet, goes into the heatsink, through the microchannels, out, and it gets up into the tank, back into the pump, and the cycle continues. The primary benefit is thermal performance. And so that means you can cool chips with high TDPs, but you can also do stuff like high temperature immersion, or HTI, which is a concept that we've been working on with Intel since the beginning of the year. So HTI refers to immersion cooling using a fluid inlet temperature of 60 C or greater. And you can do that because the lower power components on a server, they're designed to be cooled in air. And when you put them in an immersion tank at typical immersion cooling temperatures of, let's say, 30 to 40 C, they're essentially overcooled. And so at 60 C, they're perfectly happy. And so if you combine that with a forced convection technology, or like the FCHS or targeted flow for your hot chips, now your entire server can be cooled at 60 C in the fluid temperature. And with that comes great benefits at the data center level. I would say what sets Submer apart from the competition is, one, the quality of our products. Number two, our global outreach, our global footprint. And number three is our partnerships. So we have a truly global team. We've got offices and labs all over the world. That allows us to closely work with our clients and quickly respond to their needs. It also keeps us abreast of regional differences and trends. And we have a very close relationship with our tech partners. And that allows us to keep innovating and stay abreast of, I guess, the general direction of the broader market. And so when you're buying a system from us, you're not just buying one that's high quality, you're buying one that's ahead of the curve, essentially. If you'd like to learn more, visit our website at www.submer.com, and we'll be excited to connect with you.